I managed to join even though the borders are closed and we have all the tricky things happening in 2020. Let me probably start. I'm also happy that you guys ask your questions. I'm happy to see the familiar names in the question box here under the Q&A button that I have. So if you have any, please type there. Let me try to share my screen and start the presentation. So can you see my screen?
Yes, I do.
Nice, thank you. So this talk was supposed to be in March, and the topic was from the March. So back then, PostGIS was at version 3.0, which was hot and new back then. And you know, like half a year passed, and we are now waiting for 3.1. But still, 3.1 is not yet released. So let's talk a little bit about 3.0. You may think that I will read the changelog aloud, and that's generally what I will do. I hope that although there will be some interesting parts in it. So generally, who am I? I'm Darafei, I'm from Minsk. I'm located in Belarus and usually travel around the world, but this time you can see me at my home. I'm also organizer of DOI GIS community. So if you speak Russian and you have a question about something in Belarus or something that you believe a Belarusian community might know, you're free to join the Telegram group. At the daytime, I work as a head of product at Contour. Contour is a company that specializes in spatial analytics and disaster management, which makes us very contextual for 2020. And I hope to show some of the use cases that we covered. And also, I am PostGIS steering committee member. So if you want something done in PostGIS, I'm one of the persons who you need to convince to make this done, or well, feel free to send your pull requests. I'm also a maintainer of GitHub for PostGIS. Also, I worked in many different projects. So if you know Maps.me, World of Tanks, OpenStreetMap, Cosmos Nimki, or ever tried to take a taxi in New York, you may have used some of my work. So a little bit about versioning. You know, there is a chart on how the version releases progressed. So 2019 was a significant year in the history of PostGIS. We changed the major version. We only did it once before. So there was a PostGIS 1.0 and 2.0 in 2012, and now it's 3.0. Changing the major version means that there are major changes that are not backwards compatible, and that's for a good reason. So generally, how did we do it? Well, before COVID came, we all met in Boston in September 2018 on the as a steering committee and developer meeting. We discussed a lot of the plans that are going to be for PostGIS 20 version for 2019, which is 3.0. Then in May we met again in Minneapolis. There you can see at the background, you can see all the plans that were checked, and some of them are still work in progress because we have a lot of plans. This is all our development team: Paul Ramsey, Regina Obi, Darafei, which is myself, and also Raul, who is working on MVT. Yeah. So what are the improvements? So my topic, the thing I was working on, is improvements in TIN, which is a triangulated irregular networks. I will talk a bit about that later. Raul worked on Mapbox Vector Tiles. So Mapbox PostGIS now has one of the best implementations of Mapbox Vector Tiles that are available in the server-side infrastructure. There were also improvements in spatial indexes. We split off the raster extension, which caused a lot of problems with the extension infrastructure in Postgres, and we also solved it. We greatly improved stability, so a lot of topology exceptions, crashes, and stuff like that got fixed. And one of the good parts is that we removed a lot of old parts, a lot of legacy functions that were not really used by anyone, that had a better way of doing the same thing. And obviously we added some. So a little bit about the triangulated irregular networks. So I hope you can imagine what that is. If you cannot imagine, please look at your screen. This is an example of 2.5 dimensional triangulated irregular network, which has generally a height or some value assigned to it, and a two-dimensional plane where all the triangles lie in. Why do we even need it? So how did I came to working with the team? So in 2018, I had a discussion on the IRC channel with some of the PG routing developers, which were looking for a way to replace some of their old functions that were not really supported with some of the PostGIS functions. So as a result of that, I wrote a post on how exactly you should work with isochrones and how you should build them. Here on the image, you can see the working isochrones built for our local meetup space. And here you can also see that it follows the roads. It follows. It is curvy, and sometimes it has a really complex geometry. So to get to the back of this closed space, you have to walk all around the block, just because it's a closed space. So when I was writing this post, I actually hit 6 issues in PostGIS that tried to make this impossible. I obviously made some hacks and workarounds to make it work, but I also, I don't like to write ugly SQL. So for the next year, I was working on fixing the issues. First of all, what you can think about is to build isochrones with the ST concave hull. Well, technically you can do that. The problem that will arise is that such cases where you will have to walk around the block will not be solved, because an isochrone is not just a shape around all of your points that are inside, but it is also a delimiting line between the points that are inside and outside. Even though this shape is closer to the area of start, you cannot. It is actually outside of a lot of the isochrones, because travel time there is huge. So one of the first things you try to do is to build the triangulation. And to build the triangulation, you need to, one of the ways to build the triangulation is the Delaunay triangulation. The normal algorithm for Delaunay triangulation takes points as an input. And for the travel times, you actually have roads. Roads are usually represented as lines. So you have lines with the travel times, and as an input, you want points. This is a problem. To do that, there is a function called segmentize, which generally you input, you pass it the threshold of how often do you want to generate points. which is a maximum segment length, and it will split all the lines along with that limit. So in 2.5, what it was doing was actually try to build this exact value that you passed, then a line of the same exact length, and then the last line could be the shortest one. So it does not look great. So what I did was to balance the functions. So it actually now proportionally divides the line. And if you try to build your triangulation this way, it will actually be nicer. Then we figured out that, it's not the right way to do it. The right way to do it is to build a triangulation from the lines itself. PostGIS didn't have such a function until 3.0. So if you passed such a geometry into PostGIS, you would get a triangulation that would actually cross the line and go to the to basically the wrong point. Of course, you can generate a lot of points along this axis, and then the triangulation will follow and generate triangles along this long line. But this also has an element of luck. If you're lucky, it builds well. If you're not lucky, there will be some issues, and some people might actually notice them. So what we added was constraint delineate triangles, which now exactly follow the lines if they are given. So the good part is that this function was already in the part of SFSeagull, so it was only a question of exposing it. You can actually pass the lines to it. And what it also does is that if your line has a z coordinate, the value for z coordinate will be passed from the input to output. So you can actually pass the data through the triangulation. It does not create any additional points. So for such a line, you will get a sharp line and a huge triangle, which is what we actually need in this plan. And the output is thin. So function called delineate triangles was outputting the geometry collection of polygons. And you can make it work with thin, but we have an actual proper primitive to deal with such surfaces. So you got your triangles, and your triangles are oriented in space. So you know that they are now, each of the vertices of them has a height, which could be also a time assigned to them. The next thing that you want to do is to clip the triangles and find the pieces of triangles that would be actually the parts of the rings for the isochrones. So originally, we got a function for that. It's called locate between elevations, which was originally used to work on the line work of your road network. Now that you have triangles, you want to chop the triangles. So it was adjusted, and now it actually accepts tins, triangles, and the polygons. What it would do with polygon might not satisfy you, but in case your polygon is a triangle, you will get what you expect to. So another thing is that after you get all these triangles into your database, you actually store them not as polygons, but as a triangle. A lot of external libraries that are used by PostGIS don't use the abstraction of triangle. One of such libraries is GEOS. It used to complain that, hey, it's not a supported geometry type. I don't know how to work with triangles. Now, internally, when you call any of the GEOS functions, the triangle will be adjusted and inputted as a collection of polygons. So it's now transparent, completely transparent for you. You just work with the tin as you would do with your polygons that would represent something similar to the tin with all the benefits of the tin. Next thing that you want to do is to probably do some 3D math on top of that. SFSeagull is an optional dependency of PostGIS. PostGIS until version 2.5 had a switch on whether you want to use the GEOS or SFSeagull for your calculations. And we figured out that this switch was never used by anyone, or when you were trying to actually use it, you would sometimes not get the results that you want. So what the steering committee decided is to remove the code for the support of the two-dimensional SFSeagull implementation. So now there is no way someone can mess with your PostGIS installation and just flip a switch and get some other crashes or different results. We had to re-implement some of the functions back with the, within the GEOS backend. Now that 3D Intersects works with the GEOS backends, even though it was not supported originally. And all of the two-dimensional and three-dimensional distances functions are now working with tins. So you can do three-dimensional stuff on that. Question is why? Generally, you know, like people are coming to the conference and say like, hey, they want Postgres on Windows. Why? The question of why is not asked. So what we did to that is that as a head of product, we converted, I made sure that we build a product around it. So for disaster management, one of the things that this whole machinery is used for is a shelter planning. So in case you are responsible for a city and you want to plan the capacity for the shelter, you can actually come to us and ask for a demo or something, and we will show you how to actually, we build an interface around it. Having all the rings pre-calculated gives us the ability to just slide a slider and see how many people are going to be assigned to the shelters and how many people are not going to make it within your time. Obviously, this is like a government relation, or it's not often in commercial structures that you have the need to plan the capacity for shelters. But sometimes you have shops, and for the shop, the idea is generally the same. You get the points, and for the points, you get the population that's within this region. If you want to open up a new place, you just drop your new place into a simulation and figure out how many people are going to be stolen from your other places, or how the delivery pattern will improve. One of the actual cases where we build a huge interface around it is a call center automation. One of the shawarma places in Minsk said, hey, we want, because of the COVID, we want to switch to delivery, and people are not actually coming to our places, so we want to do the delivery. And they started the call center, so the call center accepts a call, types the address, gets the address, knows where to deliver the shawarma, and also they get the distance, which gives you the delivery pricing. Delivery pricing is, of course, calculated by the same algorithm that I just showed. So if you want something like that, or you want to play with it, it's public. So apps.contour.io/DonorKing, you just play with it. The next thing that was happening was not my work. It was work of Raul, who implemented a lot of things in the MVT. So the first thing is a patch that allows you to pass the feature ID. So now if you want to make a front-end application that would have some dynamic interactivity on the front end for your static tiles, you can actually, and on the hover, you want to figure out which region is that. Now you can encode that into the Mapbox Vector Tiles and get a front end that would actually know what is the ID and where to pull the data from your database. Another convenience function that happened was the tile envelope. So usually it was overlooked, and people were said, like, you know, tiles that don't really belong to the database, you want to just generate it outside in your applications. But now with the MVT improvements, it makes sense that, you know, you don't need an application anymore. You just generate the whole tile in the database, and that's it. So the function was shipped. Now, if you want to know that your client passes you Z and X and Y for the tile ID, and you can actually get the bounding box for that and do the query the way you want, you like it. Another thing that got significant improvement was the change for the algorithm for clipping. The clipping was originally done by GeoS library. GeoS library is known to be not really optimized for box clipping. So there was some intention to implement the box clipping, and we've actually found the library by Mapbox that implements the box clipping in the fast way. So one of the guarantees is that it also always produces OGC valid output that is valid, and you can actually use it as an MVT. And the complexity of the algorithm is a lot lower. So you just run it and it runs fast. So now that you can have your MVTs generated in the database, you want to actually pull the data as fast as possible from the database so that it's busy with generating the tiles, not doing sequential scanning. So a lot of index improvements. One of the improvements, which is on the index of class, was on the full outer join. If you try to have several data sets that are grouped by the same geometries, and you want to, and some of them lack some of the geometries, and you want to do a full outer join, so you have all the columns, well, you write a full outer joins and it just doesn't work. The problem is that Postgres does not implement the full outer joins for any strategy, so you cannot physically do full outer join on ST intersects in Postgres. That's limitation of the upstream. But you can do that on equals. And for the equals, we actually did some tweaks for the full outer join to start working. Another thing that we did was a Hilbert sorting. So here you can see Minsk with all of the points and all of the objects just connected with a single line. So this whole image is a single line, and you can see that, hey, this is actually Minsk. This is shaped like a city, even though it's one line. So Hilbert sorting means that for each geometry, you now have a notion of previous geometry and the next geometry, which gives you a one-dimensional way to look at the set. And if you have any algorithm that works in one-dimensional space, like sorting or some other thing, you can actually run it on Hilbert sorted geometries. And sometimes it will produce feasible results. We did some experiments on Hilbert dithering, and yeah, we use it a lot now. Why is it important? This is important because having a sorting the notion of sorting for geometries allows you to construct indexes quickly. So instead of deciding building the R tree the classical way, where you just get the leaves of the tree and you walk down the tree and you figure out where exactly do you put your next geometry, you just sort them and then chop into the intervals and call those index leaves. A lot of GIST improvements were done. So if now you're trying to do a three-dimensional or n-dimensional indexation, operator classes used to work only with intersections. Now it works with overlaps, contains, within, or equal, which helps some of the weird queries that you might need. The other thing was an improvement for costing functions. Now that you can actually build, if you are building an index on geometry, comma, some value, it will be a lot more friendlier for the other columns rather than it was. And you know, Andrei Borodin, who is going to give a presentation today, he did a patch for GIST to be constructed 100 times faster, and he needs your help into improving that and actually getting it pushed into Postgres. Why does it work? Because we did the Hilbert sorting, and now we have to improve the Postgres to actually utilize it. Next improvements were in Raster. So as you know, there is a company called Facebook. The company called Facebook released a lot of data sets, and one of the data sets they released is a Facebook population raster, which is a global analysis of where do people live. And as a disaster management company, we had to work with that because that's one of the basic needs in the humanitarian space. Unfortunately, they did it in a cryptic way, and we wanted to work with it a lot faster with Postgres. So the improvements were that now you can just say that you want to tile automatically, and the GeoTIFF and the Raster to PostgreSQL will read the tile size from the GeoTIFF and adjust it to be the same. The tricky thing was that no data value was not a number. And if you know the math for the floating points, not a number does not equal anything. So everything used to break. In such a case, we fixed it. Now it works. If you have a lot of empty spaces, those tiles are going to be just skipped. So we don't keep the tile that says, hey, there is no data here in this region. And if you want to reproject your data after you do your import, you just call it as a command line parameter, and you get your data in your format and your projection that you would like to. Another reason why we had to change the version number to 3.0 was the support for Raster extension. Raster used to be a part of the PostGIS extension, and a lot of people used to complain that, hey, we don't want the whole Raster functionality, we just want vector things, we just want, or we want to isolate Raster into special permissions or something like that. So now those two are separate extensions. So you got PostGIS and you got PostGIS Raster, which depends on PostGIS. You can build actually the vector PostGIS without GDAL. I would not recommend you to do that, but if you like, you can. And also we added the function which was added in 2.5 to upgrade everything. So PostGIS extensions upgrade will take care of it, and after you install PostGIS 3.0, you just run PostGIS extensions upgrade, and that's it. Your database will be automatically migrated to the Raster, to the new extension structure. A lot more things were done. So as you may know, that there's a lot of people working on the front-end applications. They want the GeoJSON format. It used to be a pain to construct one. I added the sample to documentation to how to properly build all the structure. But now it's a lot simpler because you can just take the database row and that's it. It will be converted into the whole feature collection, which will give you all the properties, all the features, and everything like that. Now, if you cast the geometry to JSON, you will not get a string with a byte values for the geometry, you will get just the geometry as a GeoJSON. And another nice thing that saves a lot of typing was that there is a thing called, there is a projection information, and conversion from GeoJSON didn't used to set it up. And now as GeoJSON actually sets the SRID to the expected value, so it's getting the latitude longitude one if you need it, and if it realizes something that is not in the usual coordinate system, it will explicitly mark it as such. We also do a lot of fuzz testing now, so we found a lot of ways to crash your Postgres installation if you're using the older version of Postgres. They're all part of our ticket space in Track. So if you don't want your clients or someone from the front end to crash your database, please upgrade your database. And speaking about the upgrades, we got this thing called packaging, and we tracked all the packaging for all the versions for using Repology. You should remember that PostGIS is not just a single application. It's not just a single thing that is called PostGIS. It's also all of its dependencies. If you upgrade the PostGIS version, but you keep your GEOS version at something 5-year-old, you will not get the new fixes. You will not get the new stuff. Your new PostGIS will behave as bad as the previous one. So you don't usually want it, so please make sure to update all the versions. And don't mind pinging your distribution maintainer to upgrade it. Speaking about the upgrades, each version, each point release is getting a lot of fixes. So I would not go through this list, but now each version, the list is going bigger and bigger and bigger for all the upgrades and improvements that are going to happen and are happening. So thank you very much. I've compiled a list of other things that you might want to follow. The first one is a new use of PostGIS, which is a change log, which is a live change log for all the changes that happened in PostGIS. So if you ever bump into a problem and you're not using the latest version, and you're always not using the latest version since there's always a development version, you can check there and report a bug. Then the article on the isochrone. So if you're interested on how to, what were those 6 tickets that I just mentioned fixed, you can go and read it. Also go on and read a nice blog by Paul Ramsey. Don't mind going into the Mapbox Vector library if you like the geometry and geospatial algorithms. You can also go and check out our demo. We got a lot more demos, so if you would love me to show it to you, just call me. Here is a link just to book some time on my calendar. You know what? I know that this conference attracts a lot of developers, so we know we need help into improving a lot of things in PostGIS. In Postgres, we can improve PostGIS ourselves. We can always value the help in that. But for Postgres, there are several threads on Hackers. First one is a 100 times faster GIST build, which is a thread by Andrei Borodin. Help him get it. The other one is that accidentally during some change, we found that the Postgres planning was broken for BRIN indexes, which are compact indexes that can actually utilize the Hilbert sorting right now in Postgres. Unfortunately, the support for geometry was not tested and was not covered by tests in Postgres, so it was broken, and there is a thread where we need to convince the developers that it's actually broken, and it's not an oversight on the PostGIS side. And another thing, if you want to copy a lot of data into your Postgres database, you would want to save some time and get the data, get all the flags inserted and frozen at the import time, and not after that by rewriting the whole table once again by Wagyu. So that's another issue that PostGIS community will value the help with. So thank you very much. If we have some time for questions, I'm free to answer the questions. If we don't, so yeah.